Hello, ladies and gentlemen. Welcome to the pre-recorded version of the Unit 4 Microeconomics Seminar. Unfortunately, because this is pre-recording, there won't be any music tonight. Thank you. So, let's begin with a very brief review of the Unit 3 material. You'll remember that we looked at a perfectly competitive market, and we were particularly interested in what the assumptions were upon which we build that perfectly competitive supply and demand model. The keys components of those assumptions is the fact that we're dealing with the same commodity. All the buyers and all the sellers are dealing with the exact same commodity. We have no large seller who can control the market. We have no large buyer who can control the market. And we assume that our buyers and sellers have infinite knowledge or perfect knowledge so that they know what price is being offered and what quantity is being offered in all situations. Okay. In dealing with the supply and demand market, we know that all the buyers and all the sellers are going to come together and they're going to settle on an equilibrium price, okay, which will leave no surplus. In other words, no supplier is going to be stuck with product that they want to sell at that equilibrium price, and no buyer will want to buy product at that equilibrium price and not be able to find a willing seller who wants to sell to them at that price. That's what equilibrium is. Okay? Now, we created a demand schedule, and we started off with, again, looking at how demand can function. And if we encounter a situation where the problem either tells us that there is a change in price or that the action that the problem defines results in a change in price, and if we're talking about the demand, the consumers that want to buy the product, we know that if that price changes to a higher price, less is going to be demanded. If the price goes down, then we find that more is going to be demanded. Just as in the examples that I used last week in the gasoline example, when we saw prices of gasoline going up to $10 a gallon, we found that people bought very few gallons. When the price went down, heaven forbid, but if it would go down to $1 or even 35 cents, people would buy a tremendous amount of gasoline at that lower price. So we saw that we could have a new demand curve that is created, and it could be shifted to the right if more was going to be demanded at every price. And we found that there could be a possibility of 5 different situations which might cause that demand curve to be shifted to the right. And we looked at each one of those situations. Now, by now you probably know that any supply and demand problem you look at is probably going to have one of these 5 reasons if it relates to demand, either causing the demand to shift to the right, or if the opposite of these situations were to occur, the demand would shift to the left, meaning that less would be demanded at each price. Okay. Then we looked at the suppliers, and the suppliers have a totally different rationale. The suppliers are really looking at when the price is very high, they want to supply a lot of the product because they can make a lot of profit on it. But if the price falls very low, they don't want to supply very much at all. And so therefore, they can't make any money at the low price. Now, there are always some suppliers who would supply some at a very low price. Normally, those suppliers are either much more efficient than other suppliers and have much lower costs, or they have a supply that they're trying to get rid of. Okay? So, in either event, as the price lowers, there will be some suppliers who would be still willing to supply at that lower price. As the price increases, though, now we have more and more suppliers who are willing to supply at that higher price because they can make so much more profit. Okay. Now, we also saw that there can be situations, and again, there's 5 of them, which would cause more to be supplied at every price. And again, your problems, when you look at supply and demand problems, well, if they relate to supply, they'll normally relate to one of these 5 situations, either increasing the amount that's going to be supplied, shifting the curve to the right, or the opposite of any of these situations would cause suppliers to supply less at every price, and our curve would then be shifted to the left. Okay, now when we combine the supply and demand curve, we find that there is some price at which the amount that suppliers are willing to supply at that price is exactly equal to the amount that consumers are willing to buy at that price. And so at that point, at that price point, where the amount demanded and the amount supplied is exactly equal, that is the equilibrium price. In our example here on this graph, we see the price would be $5. We see the amount both demanded and supplied would be 6, whatever it is. And again, remember, if we were talking about the entire economy, we could be talking about 6 million or 600,000. What the 6 is irrelevant because it depends on what the commodity is that we're talking about. Okay. So the key to equilibrium in a free market is the fact that at that point there is no surplus, there is no shortage. That means, in effect, as it says here in the sign, nobody can be made better off. That is the absolute best situation. Okay? And you can't make somebody better off unless you make somebody else worse off. And we'll see that later in the course when I think maybe it's Unit 6 if I'm not mistaken, when we get to the area where we have the government affecting price controls. So we'll talk about that later in the course. And we'll see how some people will be made better off, but other people will be made worse off. Okay. Now, you had an assignment problem that either in Unit 3 or it will be in Unit 4 because you had it in Unit 3, I'm sorry, where we started with a supply and demand where we had just the United States as the market for this particular product, and then we had suppliers supplying that market. So that was our original demand curve, and it's the one that's marked D1 on this graph. And I realize this graph has a lot of stuff on it, but if you read the numbers on the right side in the yellow block, you'll see where we're going with this. Okay, and they should comply with the little green circles with the numbers in them on the graph. So what ended up happening is we had new demand because we were now able to sell the same product not only in the United States but also in Germany. And with the ability to sell the product in Germany in this particular example that I'm using in the slide, we now have a combined US and German demand, which gives us our second demand curve, which is shifted to the right. And we see, just looking at the graph, and again, you could go back to the numbers that we used for this, but looking at the graph, we see that the suppliers saw that shift to the right of the demand curve as a bidding up of the price. And we know that if suppliers see a higher price, they will supply more. So they started supplying 9 million in this case instead of the original 6 million at this new higher price. And the price had risen from the original $5 up to $7. Okay? And so we were able to establish what the new equilibrium was, what the new increase in price was, and what the new increase in the quantity demanded. But then our problem asked us something else. It said, what about the amount now purchased by the United States alone? Well, they still have their original demand curve, okay, or demand schedule, which said that at $5 they were willing to buy 6. At $7 they were not willing to buy 6 anymore. Now they're only willing to buy 3 at that new higher price. So we see the addition of the new consumers wanting to buy the product has squeezed out some of the sales or some of the purchases that the original consumers would have bought. Okay? Why? Because they drove the price up. So what we end up with is the U.S. in this case, or the original consumers, experiencing a higher price. Price rose from $5 to $7, and at this new higher price, they will buy fewer, even though the total equilibrium is now total consumption of 9 at that price of $7. So you see how we combine the two in that situation. Now, you probably remember me talking last week about the fact it's nice to have a roadmap on how to go about solving these supply and demand problems. And so we provided that. It is in doc sharing. And there is a link in last week's announcements to a special video that will walk you through the steps on how to use the supply and demand roadmap or questionnaire as a scrap paper version of doing your analysis, so that you can doodle it out and see what happens to the curves and what happens to the price. Remember, in supply and demand, we're always asking, what is the new equilibrium price? Was it higher or lower than before? What is the new equilibrium quantity? Is it higher or lower than it was before? And why? And then if there's something else involved, like the question of what did the original consumers now do at this new equilibrium price, then we answer it likewise. Okay? So this gives us a way to get to that. So obviously, if you have any questions, since this is a pre-recorded seminar, you can email me or contact me by phone and let me know what your questions are, and I'd be happy to work with you on that. So with that said, we now want to move into Unit 4, and we're going to be talking about the consumer side of things and how much satisfaction consumers get from various things. Okay? So let's start off with a hypothetical situation. Let's pretend that you have graduated and you've moved to a new kind of job, one you didn't have before, and you're now working for a clothing retailer. And the boss calls you in one day. You're a manager. He's going to make you a manager of this dress department. And your job is to do something, whatever it takes, in the way of pricing strategy to increase the amount of revenue that your department generates. That's all the boss wants from you. He's going to give you a reasonable period of time to do that. But it's up to you how you change your price to accomplish that. You know what the starting price is, as you see here, just under $100, and you're selling 35 of these dresses a week. Okay? And you're making a certain amount of revenue from that. Now the question, the boss says it's up to you whether you increase the price to get more revenue or whether you lower the price. Now, of course, your boss knows you took microeconomics, so he knows that you know a little bit about this. Okay, so you're now caught in the horns of a dilemma. What do you do? Do you lower the prices in the hopes of getting so many more customers paying this lower price that now you're going to make more total revenue in the end? Or do you raise the price knowing that you will lose some customers, but if you only lose a few of those customers, okay, then maybe all the customers you have left paying this new higher price will give you more revenue. Maybe. Or maybe you'll lose so many customers if you raise your prices that you end up with less revenue. And just like lowering the price, you may lower your price, you may get a lot more customers, but at that lower price, you still may not have enough extra customers to generate you more revenue. So you're kind of caught betwixt and between. How in the world are you going to solve this problem? Well, we have a way to do that. Okay. Well, first off, we need to analyze what the situation is that we're starting with. Okay. And what we're going to do is change our price a little bit and see what happens to the demand for our product. Okay. So we're going to raise the price by about $25, okay? And what we find is that the percentage change in our price going from 199.95 to 124.95, okay, ultimately our percentage change in price is going to be about 5.56%, okay? And when we compare that with the change in the quantity of sales, our sales went from 35 sales down to 33. Okay, so we lost a little bit. We lost about 1.47% of our sales in that particular situation. Okay, and so we know a little bit about this. You'll notice a number way over at the far right on this table. It says DPE of minus 0.26. Okay? What that is measuring the price elasticity of demand, which is what you're studying this week. Okay? And how we go about doing that, that's basically the percentage change in price compared to the percentage change in quantity sold at that new price. And so there's a formula to compute that. And basically, you'll see here there's what we call the midpoint method. And it's a series of divisions. We start off with the main division. And in the numerator of that division problem, we have another division problem. And the bottom of that, or denominator of that division problem, is another division problem. So what we're doing is taking the new quantity sold minus the original quantity sold, and we're dividing that by the total of the two quantities sold, the original and the final, and dividing that answer by 2, and then dividing it into the change. And that's going to give us that number that we're looking for on the top of our equation. Okay? We do something similar with the change in price. Okay? Taking the original price and subtracting it from the new price, and then adding the two numbers together and dividing by 2, and then that whole number gets divided into what we found at the top. And in this case, our answer is that final answer way over on the right of the screen that says 0.26. Okay? What that number is actually giving us is the slope. And here's the actual computations, just so you can see how we arrived at them. Okay. So that's plugging in the actual numbers into that formula. And when you see the 0.26 at the far right, and what that 0.26 is doing is giving us the slope of this demand curve between these two prices. Now you see a very faint blue line. It's almost but not quite straight up and down. Think of that as the demand curve. And this number, this 0.26, tells us how steep that number is. It is the slope of the number, of that line. Okay? So now we have one set of numbers. We still can't answer the question because we don't really know how far we can raise our price and what's going to happen. So we'll do the second experiment. Okay? And this time we're going to go from the $124.95, we're going to increase our price to $157. And I haven't gone through shown you all the calculations, but if you look at the bottom of that line, it says third experiment. You go all the way over to the far right, and you'll see that we've increased our revenue by another $586 and some change, and our new price elasticity of demand is a minus 0.42. A number that's still relatively small, smaller than 1, okay, smaller than the value of 1. And again, that's the slope of our demand curve in this particular price range between 124.95 and 157 even. Okay, and we see that our demand curve has shifted slightly, not shifted, but tipped, if you will, slightly away from straight up and down, but not very much. It's still relatively straight up and down. So we can do a fourth experiment. This time we raise our price from 157 to 199.95. Okay, now we practically doubled our price. Again, we see that our price elasticity of demand is still way under 1. It's still 0.44. And our demand curve in this area is likewise almost straight up and down. What this is telling us is in these three price ranges, as we increase our price, we are losing relatively few customers. And you'll notice the change in revenue, the second from the right-hand side column, we still have a positive number. This time we raised our prices and we ended up adding $688 and some change to our total revenue. So far we're doing good by raising our price. Let's see what happens when we raise it one more time. This time when we go above that $200 mark, up to $243.95, now we see that we've raised our price, okay, and we've lost a lot of customers. As a matter of fact, if you look at the percentage change in price, you'll see it's a 4.96, but our percentage change in the quantity, and again, this is using the midpoint method, so that's why it doesn't come out to what you would expect it to be. But you'll notice that we had a 10% change in the number of people who purchased. Okay, so 4.96 into 10, that says that for every 10% that we change our price, we're going to lose 20% of our customers. That's what that 2 minus 2 over in the far right-hand corner tells us. Okay? So therefore, we see that we suddenly have a big drop, and notice now that by raising our prices, we've lost so many customers that now we're losing total revenue. Boss is not going to be happy with that. So let's do it one more time to confirm that we're in that proper area of the demand curve. And lo and behold, now we see our demand curve is even flatter. It's not perfectly flat, but it's way flatter than what we originally started at. Here we are at nearly $300, $289.95, and this time we lost a lot of customers. We dropped down. We only sold 5 that week, okay? And we lost almost $4,000 in revenue. So what have we learned from this experiment, or this series of experiments? Well, first off, we've learned that our demand curve changes at the shape as the price bracket changes. In the early brackets, from the $99 up to the, looks like the $199, our price elasticity of demand was a relatively small number, which meant as we increased price, we lost very few customers, and therefore we were increasing our total revenue. But once we increased our price above that hypothetical point, and no one knows what it is until you do the experiment, our customers no longer felt that that was a fair price, or the majority of our customers no longer felt that was a fair price for that product. And therefore they demanded fewer of them. And we see that our price elasticity of demand is a much bigger number than 1. In our 5th experiment at $243, our price elasticity of demand jumped to 2.02. And all the minus sign means is as you increase price, you lose customers. If we had a plus sign out there, as we increase prices, we'd increase customers, which doesn't make sense. Okay? But that's what the minus sign means in front of those DPE numbers, or price elasticity of demand numbers. Okay? And then we saw that even though we took a relatively small percentage jump in price above that $243 point, okay, that we lost even way more customers that next time around. Okay? So our percentage quantity change in customers went from 10% to 28%, but we only had a 4% change in the midpoint of the price. Okay? So that purple demand curve is really flat, getting very flat. Okay? So we were able to find out something about our demand, and we noticed that the shape of our demand curve changes over different price ranges. Okay? And so the whole reason that we study this is try to determine when and where we can increase our total revenue. So the key number when you compute your price elasticity of demand, and by the way, you will be doing that in one of your assignments, is if the answer that you get is smaller than 1, then what that's telling you is in order to increase your, well, first it tells you that if you raise prices, you will lose very few customers because your demand curve is almost straight up and down, and that your price elasticity of demand answer is smaller than 1. And in terms, we would say that your demand is inelastic. It's not very elastic if it's smaller than 1. And therefore, to increase your revenue, you need to raise prices. All the customers you have left paying more money will return you more revenue. But remember, that only works in a certain price range. Once you get beyond that range, then, in this case, you start to see a price elasticity of demand that is bigger than 1. The answer much bigger than 1. This tells us that our demand is very elastic, meaning the more you raise prices, the more you're going to lose a lot of customers. Now, if you were operating in that range and you want to increase revenue, what you need to do is lower the price so you get many, many more customers, and therefore all those customers paying less money than the original customers were will give you more revenue. Okay. So as you can see from this little experiment, we have demand curves that can have any shape from straight up and down to flat. Okay? So somewhere in that range. Now normally I draw the demand curves as a 45-degree angle because it's convenient. Okay? But realize that we do have demand curves where the slope of the demand curve can be different. Okay? Now let's think of an example where we had a perfectly elastic demand for a given product. Okay? And what do we mean by this? We mean that as the price increases, the amount demanded of that product stays the same no matter what. Let's have an example. Let's assume that your child is very sick. You take them to the doctor and the doctor says your child is deathly ill. There is only one medicine that will make your child better. You must get it now. And that medicine is $10 a shot, and the child needs 1 shot. And he will be better, he will not die, or she will not die. Wouldn't that be fantastic? Are you going to hesitate to go buy that medicine? No, at $10, you're going to buy it immediately. Okay? You're going to save the life of your child with that 1 shot. Now, if the price of that medicine goes to $100, you're still going to go buy that medicine immediately, no matter what. You're going to spend the $100. Even though you might have been saving the money to go buy groceries this week, you're going to go get the medicine to save your child's life. If the price of that medicine were $1,000, now it's going to be a little more difficult. Okay? But you will do what it takes to get that $1,000. Even if the price were $10,000 and you didn't have insurance. Wouldn't you be willing to mortgage your house if you had it already paid for? Wouldn't you be willing to borrow money from friends and relatives to get enough money together to get that medicine? Okay? That's how critical that medicine is. That is an example of a product that has a perfectly inelastic demand. It does not matter what the price is. People will buy that product at the same quantity. It's not going to change the quantity based on price. Okay? We call that a perfectly inelastic demand. Now remember, as we had our first 3 experiments with our dresses, we saw that our demand curves were almost straight up and down, but not quite. And so What that meant was we would lose a few customers as we raised prices relative to the amount that we raised the price. Okay. Now, again, if you're the person put in charge of the sales, how are you going to go about finding this out? Well, obviously, you have to do a series of pricing experiments to find out what is the market for your particular product. Again, just like we did, you measure the sales at a starting price, change the price by a certain amount, measure what happens. If you are lucky enough to have a wide variety of outlets for your product, maybe you only change the price in certain target test locations. Okay? Then you change your price again and measure again, because it's not enough to have one data point. You need multiple data points, and especially if you're trying to find out at what point does your elasticity, price elasticity of demand change to where it would be dangerous to raise your price anymore. Okay? So once you find that out in your test, now you know what to do with the rest of your marketing. So obviously we have a tool, and if you just compute that price elasticity of demand, you can tell where what's going to happen to your demand within that price range, and you know how much you can raise your price. Okay, now it is possible to have other kinds of elasticities of demand. We have something we call income elasticity of demand. Now remember, price elasticity of demand measured how much the demand for your product changes as the price changes. Well, income elasticity of demand says how much will the demand for your product change as the income level of your target market changes. Think of it this way. Imagine a person who's going to school and making slightly more than minimum wage. Maybe they just don't have a whole lot of money, but they're really struggling. But they have enough to eat each week, and enough to put gas in the car and put basic clothes on the family's backs, and they keep a roof over their head. They got the basics, okay? But they're not rich by any long shot of the imagination. Okay? Maybe when they take the family out to dinner, maybe they stop by a fast food joint. Maybe they hit a Wendy's or a Hardee's or whatever, okay? A McDonald's, whatever. And that's the night out. Friday evening you're going out shopping, you're doing a few things, and you're going to take the family, go get dinner. You'll hit, a restaurant like that. After you complete your education and you move on to that more professional job, and now let's say you're making money up in the $50,000, $60,000, $70,000, $80,000 a year. Okay? You're starting to make middle income money. Okay? It's much more likely now that when you take the family out to dinner on Friday night, you may skip the McDonald's or the Wendy's or the whatever, unless you're really in a big hurry. You may take them to a little nicer restaurant. Okay? Well, the demand for the food at that nicer restaurant is an example of as people get richer, there's more demand for that. Okay? And so we see that same thing. And we can also have a situation where the richer people get, the less they buy of something. So if we see a community where more and more people are becoming successful financially, either because of their education or whatever, and we find that they stop buying as much of the cheap stuff. Okay? So maybe the example that I gave earlier, the fewer meals at McDonald's would be an example where the rich people are buying. The richer the people are, the less they're buying at that establishment. Okay? And again, nothing is ever absolute, so there's variation in everything. But you at least get the idea that there are some products that the richer you are, you're more likely to buy. So for example, if you're relatively low middle income, you're probably going to be dealing with a used car, with maybe a basic car, a Chevy, a Toyota, whatever, basic cars. But as you get richer and richer and richer, you may be tempted to buy that Mercedes or that Porsche or that whatever. Okay, you fill in the blank, but you get the idea. Okay, so There are other things that we could measure elasticity of, but those are the two that you'll be looking at with your assignment. Now, we have an example too of a normal good versus an inferior good. And this again comes back to that income area, so that if a person increases their income and they buy more of that good, whatever it is, then that's a normal good. The richer people are, the more they buy of that thing. If, as people get richer and richer and richer, they buy less and less of something, then that would be an inferior good that only the poorest of people were buying. Okay? It's kind of like spam. When poor college students are going to school, maybe they buy a lot of spam and ramen noodles to eat, okay? Because that's cheap, right? But once they get their degree and they're out in the working world and they're making some money, now maybe they buy a little bit more healthy food. Okay? Now we also have a situation where we have complementary goods. Okay, that's two goods that go together. The example I have here is coffee and donuts. A lot of times people buy, stop in for coffee, they'll get some kind of a pastry to go with it, some kind of a sweet. Okay? Think of peanut butter and jelly. Sometimes those two things go together. Okay? So there are many things that are paired together in our mind. When we get some of one, we'll normally get some of the other. Across price elasticity is where we look at the change in price of something, and when that price changes, it affects what we buy of something else. You might remember when we were talking about, was it the demand curve that I was talking about, the coffee and tea? Anyhow, yeah, it was when we were talking about shifts of the demand curve. So I'll just reiterate it very quickly. Remember, I used the example of a Starbucks coffee costing $4 and a chai tea at a Starbucks costing $4. And so if you didn't really care which one you'd buy one or the other. It didn't really matter. You were willing to, one day to buy coffee, one day to buy tea. It just didn't matter to you. But if you come in one day and the price of the tea is $10 and the coffee is still $4, you're probably going to buy the coffee. Here, the change in the price of tea would cause an increase in the demand for coffee. That would be a cross-price elasticity, where the complementary goods, if you lower the price of coffee, you're probably also going to sell more donuts. Okay? So the two go together. And then everything we've said about elasticity of demand has its corollary for elasticity of supply, because suppliers' supply curve also can have a different degree of steepness depending on their situations. Now, we're not going to spend a lot of time going into that in this unit, mainly because I don't think you have any questions on it, but there is some material in your reading about that. You do want to pay attention to it. Because invariably, if you're working in the business world, you're going to be on the supply side of things also. So, that said, we've covered a wealth of material. I'd like to change topics for a few minutes, and let's talk about something else. Let's pretend that you got up this morning really early. You had to be up extra early. You had to rush out because you had a job that you had to get to. And you didn't really have time for a decent breakfast. You grabbed a quick cup of coffee, and as you were going out, you saw a couple sticks of celery. You grabbed those and wolfed them down, which has virtually no calories in it. And you get to work, and they take you off site, and you're working all day, and there's no place to get anything to eat. And then they make you work overtime, and you're working all day, and you are just starving. And now it's time to head home, okay? It's late in the day, and you go buy a hamburger joint. And you say, I just can't go any further. I've got to stop and get something to eat. Okay? So you go in and you do that. You sit down, you order your burger, and you sit down, and just as you're sitting down, just as you're ready to take that first bite, up comes a Kaplan student, an economics student from Kaplan University. And they say, would you mind if I ask you a couple real quick questions here about that burger I see you're getting ready to eat? And you say, okay, fine, sure. I go to Kaplan too, so I don't mind answering your question. What can I help you with? And the person says, could you tell me how important or how much satisfaction that you think you're going to get from that burger, just give me a number from 1 to 100. What do you think that would be? Okay? And now, if this were not a pre-recorded seminar, I would be asking you to respond to that. What number would you give that very first burger? You are so hungry. You just got to have it. I mean, you're just famished. You're lucky you can think straight or sit up straight. You're so hungry. Okay? So, you give it a number. We don't know what that number will be. It'll be somewhere between 1 and 100. Okay? What about the second burger? After you've gotten that first burger down, now you've sated some of your hunger. Okay? You're still hungry. These burgers aren't very big. So maybe you go ahead and order that second one, and right away the Kaplan student comes up to you and says, "Oh, I see you've ordered a second burger. Could you tell me how much satisfaction you're getting from that second burger using that same scale from 1 to 100? What do you think that is?" Well, maybe you're not near as skinny and sexy as this girl in the picture is. Maybe you're into big burgers, and you work on that third one, and again, the Kaplan student sees you coming with that third burger and says, "What score would you give that one from 1 to 100? And finally, we look at the fourth burger, and the Kaplan student asks you, "What score would you give this?" And again, I do this live in the seminars, and I have people giving me the numbers, and invariably the numbers come out something like this. The first burger gets a really high score, a 90 maybe. The second one gets a little lower score because the person's really, really hungry yet, but not nearly as high as the first one. The third burger gets a pretty low score. By the time they get to that fourth burger, if they even give it any score, if they even get it, it has an extremely low score. Now, what the MU is, we have some kind of a number that we're measuring. And what are we measuring? We're measuring how satisfied you are. How much happiness, how much goodness does it give you? Well, another word for goodness is how much utility or use are you getting from that burger or from whatever it is that you're purchasing. And because we're measuring the amount of utility or satisfaction from each one of those burgers, not the total of all the burgers, but for each one, how much it gave you, well, we know when we measure the amount of one is giving us, that must be a marginal number. So we're measuring the marginal utility of each one of those burgers. And we see the first burger in this case gave us a 90 marginal utility. The second burger gave us 60, the third burger gave us 30, and the fourth burger gave us 12. Something immediately obvious is the more we get of something, that next one will give us less satisfaction than the one before it. Now, there's one other thing we really need to know about this satisfaction level or marginal utility, and that is how much did we have to pay for each one of these burgers? And we see the price was $3. So if we divide that $3 into whatever the total amount of satisfaction or marginal utility that we got for each one of these burgers, we can come up with a marginal utility per dollar. And what we're asking ourselves when we do that computation, we're saying, how much satisfaction per dollar spent am I getting on that last one? Okay, so we see now our first burger gave us 30 marginal utilities per dollar. And by the way, we often call these utils because marginal utilities is not quite the correct word. So we say the utilities, each one of those would be a util. So the second burger gave us 20 marginal utilities per dollar spent. The third gave us 10. The fourth one only gave us 4 marginal utilities per dollar. Okay, so we've got prices. Now, one of the reasons that we compare marginal utility per dollar, because again, as I said, we want our dollars that we're spending to give us the most satisfaction that they can. It is especially important when we're comparing the satisfaction or marginal utility we get when we're purchasing 2 different items at the same time. Okay, well, back up before I say that. Okay, what we have just learned from these numbers is there is a law in economics saying that we have diminishing marginal utilities. What that means is as we increase the number of things that we are getting of the number of the same thing that we're getting, each one will give us less marginal utility than the one before it. Remember that. That's an important statement. So the law of diminishing marginal utility says that the next item that we get will give us less marginal utility than the same item, the one before it, that we got. Okay. Now, one of the things we were talking about in comparing our marginal utility per dollar is the fact that when we are purchasing two items, so here we have drinks, okay? Now, we were able to drink water when we were out on this work site, so we're not as thirsty as we were hungry. Okay? So we found out that the first drink, soda, gave us a total of 60 marginal utilities for that one drink, and it cost $1.50, so the marginal utility per dollar for that drink was 40. The second drink, because we weren't nearly as thirsty, only gave us 15 marginal utilities, and that equaled 10 marginal utilities per dollar. Now, when we are purchasing two items, and by the way, you have a problem on this too, and I think it relates to bracelets and sodas, if I'm not mistaken. Anyhow, whatever the item is, we want each dollar to give us the same marginal utility per dollar spent on each item. So we want the most satisfaction we can get, and we know we're going to have the maximum satisfaction when the last dollar spent on each thing gives us the same marginal utility. So how does that work out? If we look here at the last one we bought the third burger. It only gave us 10 marginal utilities per dollar, and the soda gave us 10 marginal utilities per dollar. Well, that looked pretty good, okay? We must be maximizing our utility, okay? Because the marginal utility per dollar for the last burger and the last soda are equal, so that tells us we are maximizing our utility per dollar, okay? If we had added one more soda, then we would have found that it gave us very little marginal utility. It only gave us 3 marginal utilities, and the marginal utility per dollar was only 2 because we had to divide it by $1.50 to buy the drink. We compare the 2 marginal utilities per dollar with the 10 marginal utilities per dollar for the third burger, and they're not equal. So in that situation, 3 and 3 would not be giving us, given these numbers, would not be maximizing our satisfaction per dollar. Okay? What happens if we add a fourth burger but only stay at the 2 drinks? Well, here again, our fourth burger gives us 4 marginal utilities per dollar, and our second drink only gave us 10. The numbers are still not equal. They're far from each other. So therefore, we are not maximizing our satisfaction or our marginal utility per dollar. Okay. So let's take an example of a situation somewhat similar to what your problem gives you in your assignment. Here we're going to say that we have purchased the third burger. It has given us a total of 30 marginal utilities, and it cost $3, so that was a total of 10 marginal utilities per dollar. And we had our third drink, and that third drink only gave us 2 marginal utilities per dollar. And the question says, are we maximizing our satisfaction? Now again, in a live seminar, I would ask you, and I'd be waiting for answers. Okay? But I think you can see that no, you're not. The 10 and the 2 are nowhere near equal, so therefore you are not maximizing your satisfaction. Now the assignment problem is probably going to ask you, should you get one more of the one thing, in this case burgers, or should you get one more soda in order to maximize your utility. Okay? Well, let's look and see what happens. If we added a fourth drink, okay, and we went to 1.5 marginal utilities and a total of 1 marginal utility per dollar compared to the 10 for the third burger, well, we're still not close. We're nowhere near close. So we have not maximized our utility yet. Okay? What about if we stay with our third drink and we add a fourth burger? Well, again, they're not exactly equal, but the 2 and the 4 are a lot closer than any other combination we've had. So although they are not equal, and again, we don't know what the number would be, but we know by adding one more burger, we're going to get a smaller number, and a smaller number should bring us closer to the drinks. Okay? So although they're not equal, they're a lot closer to being equal, and that's what we would recommend. So we would recommend in this situation that the person add one more burger to maximize their marginal utility per dollar, maximize their satisfaction by making the 2 marginal utilities per dollar closer together. The key here is understanding that the law of diminishing marginal utility means that if you add one more of the item, that next item that you add will have less satisfaction than the one before it. Okay, if you have any questions, again, make sure you contact me either by email or by phone, and I will be happy to answer your questions. Okay? So what do you have to do this week? Well, obviously, read my announcements. Make sure, and by now you should be aware that one of the announcements says that I'm not present for the seminar. That's why you're looking at this pre-recorded seminar. Make sure you do your readings. We've got chapters 6 and 10. The flashcards, I've had people ask me about the grading on the flashcards. The flashcards, although they show the number correct and how you're doing on the flashcard quiz, we do not grade that as part of the 1,000 points in your grade for this course. Those are learning tools to assist you in better understanding the material. That's their sole purpose. So it is not a graded item, so don't worry about it. Okay? Do them, but don't worry about the grade. Do post to the discussion. That is a graded point. Do the assignment. That is graded, as is attendance in the seminar. Of course, you know the magic answer at the bottom here. When you have a question, come to me. So, what is your discussion about this week? It's going to be comparing marginal utilities in different situations. One of them, you're given a whole bunch of pizzas for a month, 2 pizzas a day for a month. That's lunch and dinner. And how excited are you going to be that last day of the month when you get 2 more pizzas? Okay. The other situation is you're given an unlimited amount of gas for a certain period of time. Oh, that could be quite valuable. So, you know the rules on discussion thread. Make sure you get everything in. And again, because I'm traveling, I may not be as active in this week's discussion. Your assignment this week is going to look at diminishing marginal utility. Ooh, something we just talked about. And how to maximize your marginal utility per dollar, just as we talked about with the burgers and the drinks. Okay? You're also going to have a question on price elasticity of demand, where you get to compute that. And remember that if the number is bigger than 1, then you have an extremely elastic demand. And what is that going to mean you're going to need to do? It's going to mean if you have elastic demand, that means if you raise prices, you're going to lose a lot of customers. If you lower prices, you're going to gain a lot of customers. Okay? If your price elasticity of demand is very small, smaller than 1, then if you raise prices, you're not going to lose very many customers, and all those remaining customers paying the higher price will give you more revenue. By the same token, if you lower prices in that range of price elasticity of demand smaller than 1, you're only going to lose a few customers, but those few the ones remaining paying the smaller price will probably give you less income. So if your answer comes out to be smaller than 1, you probably want to raise your prices. If the answer comes out to be bigger than 1, you probably want to lower your prices. Okay? And then there's also a question about the income elasticity of demand. And if the answer is bigger than 1, then as people get richer and richer, they're going to buy more and more of that product. If the answer is smaller than 1, as they get richer and richer, they're going to buy less and less of the item. Okay, you know how to contact me. Nothing major there. Nothing's changed. And with that, thank you very much. And I should see you next week in Unit 5's discussion. Thank you.